Assalamu alaikum wa rahmatullahi wa barakatuhu. Once again, welcome you all students for our chemistry lecture, chapter number 7, that is modern periodic table. This is our ninth lecture for the same. Today, we are going to study blockwise characteristic of elements. Till our previous lecture, we have completed electronic configuration of the elements in respective periods, groups in block. Today, we are going to move forward towards blockwise characteristic of elements. As we have seen in the previous section that the 118th element are present in the modern periodic table. These 118 elements are distributed in 4 blocks and they are having general electronic configuration with respect to their blocks. Fine, we have studied this whole thing in detail. So the elemental properties are characteristic of the block they belong. Whatever the respective elements which is present in the respective blocks, they represent the characteristic property of the block to which they belongs. Understood, student? Here suppose the respective elements XYZ, it belongs to group 1. Then group 1 elements belong to which block? It belong to S block. So the elemental properties of these respective elements will be the characteristic of the block to which they belong. Let's move forward towards characteristic of S block elements. As we know, the S block elements consist of two groups, group 1 and group 2, where group 1 is an alkali metal and group 2 is an alkaline earth metal. All these elements are reactive metals, means they are reactive in nature and they occur only in combined state. It does not occur, these elements does not occur in free state. It occur in combined state, means it is mixed with some other elements and then we are getting these elements. So these elements, which elements? Group 1 and group 2, which are S block elements. They are reactive metals and they occur only in combined state. They are compounds, means they are obtaining in combined state, means they are compounds in which they are present except lithium and beryllium. These compounds are which compound? Group 1 and group 2 elements. Except lithium and beryllium, they are predominantly ionic in nature. Ions, as we know, there are two kinds of ions, either cations and anions. Fine. So this is because they have only one or two valence electron. How many valence electrons is been present over here? One or two. So they can lose that electron easily. If they will lose one electron, they will get converted into M plus. And if they will lose two electrons, they will get converted into M2 plus. Fine. So they have been converted into cations. Cations, the one which gives an electron and get converted into positive charge. So these elements, when they liberate, they lose one electron, they get converted into M plus. And when they lose two electrons, they get converted into M2 plus cations. And they have low ionization enthalpy. What is ionization enthalpy? These all things we are going to study in detail later in the chapters. See, as we are moving down the group, group 1, group 2. They are S block elements. So as we are moving down the group, they have low ionization enthalpy. As they have low ionization enthalpy, this will result in increased reactivity. Okay, the elements of group 1 and group 2 are S block element. As we are moving down the group, see, we are moving down, the ionization enthalpy decreases and which result in increased reactivity. Fine. These are the characteristic of S block element. S block element consists of group 1, that is your alkali metal, group 2, that is your alkaline earth metal. And these elements are reactive in metals and they occur in combined state. Their compounds are ionic in nature. Why? Because leaving behind lithium and beryllium, they have only 1 or 2 valence electrons, so they can lose it and get converted into M plus or M2 plus ions. They have low ionization enthalpy as we are moving down the group, which in turn result in increased reactivity. So these are the characteristics of S block elements. Let's move forward towards the next block element, that is your P block elements. The P block elements are from group 13 to group 18. It is present at the right hand side of the periodic table. The P block elements together with S block elements are called main group elements or representative elements. Whether S block elements are present in the periodic table, it is present towards the left hand side. While where the P block elements are present, they are present on the extreme right hand side. Okay. So these P block elements plus S block elements, they are known as main group elements or representative elements. Fine. The last group of the P block, that is your which group? That is the 18 group, which is known as zero group elements, noble gas elements, inert gases elements. Fine. These 18 group elements having completely filled shell, that is closed valence shell. Helium having complete doublet, while the remaining elements of group 18, they are complete octet, and therefore they are having very low chemical reactivity. They doesn't have chemical reactivity, they have very low chemical reactivity because their valence shells are completely filled. Which elements? Group 18 elements of the P block. Fine. So here group 13 to 18 are P block element. P block plus S block are known as main group element or representative elements. The 18 group elements are known as noble gas, inert gas, zero group elements. The elements of 18 groups, they are having closed valence shell in which helium is complete doublet while the remaining elements are complete octet. And these elements are having very low chemical reactivity. So here this is about 18 group elements of P block. Elements of group 17, they are known as halogen family. And group 16, they are chalcogens. They are known as chalcogens. Includes reactive non-metals. The electron gain enthalpy being highly negative. What is electron gain enthalpy? The amount of energy required to gain an electron. Electron gain enthalpy energy. How many amount of energy is required to gain an electron? These group elements gain 1 or 2 electrons readily and forms anions. As we know, group 17 elements require only 1 electron to attain the state of stability, while group 16 elements, they require 2 electrons to attain the state of stability. So, due to this reason, these group elements, group 17 elements will gain 1 electron and get converted into X minus anions. Minus charge for anions, okay? They will gain 1 electron and attain the state of X minus. And group 16 elements will gain 2 electron and form X2 minus anions, okay? And if they will gain, group 17 will gain 1 electron, group 16 will gain 2 electron, then they will have complete octet. They will having complete octet as that of group 18 elements. The p blocks contain all the 3 traditional types of element. Which are all the 3 traditional type of element? Metal, non-metal and metalloids. As we have seen in the figure 7.1, that the metals are placed on the left, non-metal on the right, and the metalloids in the middle along a zigzag line. We have studied this thing. That zigzag line separates metal from non-metal. The non-metal characteristic as we move from left to right increases. As we are moving from left to right, see, imagine the periodic table. As we are moving from left to right, the non-metallic characteristic is increases. Fine. Whereas it decreases as we move down a group. As we are moving down the group, it decreases. So these are the characteristics of p block elements. Let's move further towards the characteristic of t block elements. Which elements, where the d block elements are present in the modern periodic table? It is being present in the middle between S and p block. So the d block contains elements of the group 3 to 12, where group 1, group 2 is S block, group 13 to 18 is your p block, and group 3 to 12 is your d block. They are all metals. All the elements of D block are metal. The D block elements are also known as transition elements or transition metal. They form a bridge between whom? Between chemical reactivity S block and less reactive elements of group 13 and 14. It is present in an intermediate between S and P block. Fine. Most of the d block element possess partially inner d orbital. Here the last electron will enter in d orbital, fine, and that d orbital is partially filled. Due to this, d block elements have properties such as variable oxidation state. Some of the elements will having +3, +4 variable oxidation state. Some will having +4, +5 and so on. So they have variable oxidation state. They are paramagnetism. These are the magnetic properties due to which they form colors ions. These, when they forms anions, that ions will be colored. Okay, they can be used as catalyst. What is catalyst? Which increases the rate of the reaction without itself being consumed in the reaction. Fine. The catalysts are the compound which are used in the reaction to increase the rate or speed of the reaction, and at the end they regain its origin position. Zinc, cadmium, these are having configuration NS2 N-1 D10, where completely filled S and D subshell is there. Why these elements in cadmium and Hd? They are having completely filled S and D orbital, that is a subshell. Due to this, they do not show the properties typical of transition metal. Right? Due to this reason, the D block elements are present in the middle of the modern periodic table. Which blocks are D block element? Groups Which groups are d block elements? Group 3 to 12. They are all metal. They are also known as transition elements or transition metal. They are present. They form a bridge between S block and P block. The elements, most of the element possess partially filled inner d orbital. Due to this, they are having variable oxidation state. They are paramagnetism in nature and they form color compound. They are also used as a catalyst. Some of the elements such as zinc, cadmium, and Ag, who's having electronic configuration ns2 and -1 d10, where in this electronic configuration we can see that d and s subshells are completely filled. Due to this reason, they do not show typical properties of transition metal. So student, these are the characteristic of d block elements. Let's move forward towards the characteristic of last block element, that is your f block elements. The f block contains elements all of which are metal. Obviously, F block has been emerged out from D block. We have seen in the modern periodic table figure. So D block elements, all the elements are metal. So F block elements will also be metal. So here all the elements of F block are metal. And they are placed in the two rows at the bottom of the modern periodic table. What are that two rows? That two rows are lanthanide series and actinide series. Fine. From the element cerium to titanium and so these two, there are two series, that is the lanthanide series and actinide series. They are present at the bottom of the modern periodic table. Why these series are known as lanthanide series and actinide series? Because the preceding element for lanthanide series is lanthanum, and for actinide series is actinum. The atomic number for lanthanum is 57, while that of actinum is 89. Lanthanide series has been emerged out from the third group and 6th period. As we see in the modern periodic table, this lanthanide series has been emerged out from the third group and 6th period, while actinide series has been emerged out from the third group, from the same group, but from the 7th period. Fine. So F block elements, all the elements of F block, they are metal. There are two series which are placed at the bottom of the modern periodic table, that is your lanthanide series and actinide series. The lanthanide series has been named after the preceding elements, that is your lanthanum, and the actinide series are named after the preceding element, that is your actinum. Lanthanide series has been emerged out from the third group and the 6th period, while the actinide series has been emerged out from where, student? It has been emerged out from the third group and the 7th period. The lanthanide are also known as rare earth metal. It is also known as rare earth metal. The last electron of the elements of this series is filled in which subshell? In N-2F subshell. It is also known as, due to this reason, as the last electron has been filled in the N-2F subshell, they are known as inner transition element. These elements have very similar property within their respective series. The lanthanide element having very similar property with respect to their lanthanide series, while the actinide elements will having similar property with respect to actinide series. In the actinide series, the elements belong uranium, whose atomic number is 92. Beyond uranium, the elements are known as trans-uranium elements. They are known as trans-uranium elements. Why? Because all the trans-uranium elements are man-made. They are made by man. These elements have been made by man, and they are radioactive elements. They are radioactive elements. Which elements? The elements belong uranium, atomic number 92. They are all trans-uranium elements, and they are man-made, as well as they are radioactive elements. So here, student, we have completed all the characteristic of all the four block: characteristic of S block elements, characteristic of P block, D block, and F block elements. Hope you all have understood. Let's see one numerical over here. Chloride of two metals are common laboratory chemicals. Two metals have been there. They are existing in chloride form. Suppose AgCl2, MgCl2, whatever. They are being present in chloride form, and both the compounds are colorless. One of the metal react vigorously with water. They react vigorously, while the other reacts slowly. Vigorously means very fast, and the other react very slowly. So what we are supposed to do? We are supposed to place the two elements in the appropriate block of the modern periodic table. So let's see over here. Metals are present in all the four blocks. As we know, in all the four blocks, S block, P block, D block, F block, in all the four blocks, metals are present. Salt of metal in the F block and P block are not common laboratory chemicals. F block and P blocks salt, metal salts, they are not common. Therefore, the choice is between, we are supposed leaving behind F block and P block, because metal salt for F block and P blocks are not common. So we are supposed to choose between S block and D block. From the given properties, we can clarify that metal that react vigorously with water, they are S block elements. As we have studied, S block elements are very reactive in nature. So the metal which react vigorously with water, they are S block elements. Why? Because S block elements are very reactive in nature, while the other metal which reacts slowly with water, they are D block elements. Fine. So the colorless nature of the less reactive metal in the D block implies that the inner D subshell is completely filled. As the inner D subshell is completely filled, so the one which react vigorously with water, they are S block, and the one which reacts slowly with water, that is the D block. So here, student, we have completed the numericals which state that the metals, chloride metals, which react vigorously with water, they are present in S block, and the one which react slowly with water is being present in D block. Fine. Leaving behind F and P block, because salt of these metals are not common laboratory chemical. We are not going to prepare in laboratory. Fine. So there is a choice between S and D block. As S block elements are very reactive in nature, so these metals react vigorously with water in S block. This metal is present in S block, while the one which reacts slowly with water, they are present in D block. Hope you all have understood, student. Go through it. Take the important points from this. Learn some of the characteristic of S block, P block, D block, and F block. Hope you all have understood. Till then, take care, study well, do your best. Thank you, student.